Hi, and welcome to Allen High School's discussion of limiting reactants. Now, if you had me for pre-AP chemistry, this chart will be familiar, although this bumps it up a level of difficulty. If you didn't, they tended to do limiting reactants a different way. They would do two straight stoichiometries and just pick the smallest. Well, the problem with that is it doesn't tell you how many moles of the limiting in excess are remaining. I mean, yeah, you can get the moles of limiting, but the excess remaining is typically a pretty tricky part of this for students. And if you use this chart, it falls in place beautifully. So the first step will be to get to moles. So I have 43% KMnO4, and I have 63 grams of that percent by mass solution. So I can find my grams of KMnO4 is 2709 grams. Now, once I know mass of KMnO4, going mass to moles is a straight shot. Mass to moles, use molar mass. Sorry, my Mimi is a little jumpy today. 153 point, excuse me, let me erase that. Can't read it very well anyway. All right. It's times 1 mole per 158.03 grams. And that leaves us with 0.1714 moles. So I'm going to put that up in my grid. Now what's nice about this grid is if you've done all your dilutions, you can use molarity here as well. All right, second step, let's get our HCl. I have a 2 molar solution. And I need to know my moles of HCl, and remember we have to have liters, so I've got to convert that 75.3 milliliters to liters. And boy, you need to check my algebra because I'm at home doing this not feeling very well. So let's check my algebra there, 0.01506 moles. All right, now initially I don't have any moles of my products because the reaction hasn't had time to proceed to form products. Now, sometimes this next step is intuitive for people. I need 16 over 2 or 8 times more HCl than I have MnO4. And you can look at the numbers and see that there's no way I have 8 times as much. So you can try to do it intuitively. The other thing you can do is just pick one, and if you end up with a negative number at the stop point, you picked the wrong one, and go back and fix it. We're going to actually calculate that if I have available 0.1506 moles of HCl, I'm going to find out how much KMnO4 I need. And we always relate one to another in the reaction based on those mole ratios. So I'm going to need 2 moles of KMnO4 for every 16 moles of HCl that I react. So that could be a simple problem. It could have just said, how many moles of KMnO4 are needed to fully react 0.1506 moles of HCl? And if I did my algebra right, and I'm counting on you to fix it, if I didn't, I think I did, but I need this many moles of KMnO4. Well, I have way more KMnO4 than I need. So my KMnO4 is in excess. I'll put it down here to make it very clear. And my HCl is my limiting. Right? So that's a key step. That's usually going to be one of the parts that you have on an AP free response, is they will ask you this step by step. Now, a reaction proceeds until all of the limiting reactant is consumed. So it goes 100% until I lose all of my limiting reactant. So the limiting should always go to 0. So now what I need to do is move along and shift my other moles based on my limiting reactant. Well, we do that. We always gain product, so that's going to be a positive. And I'm going to multiply by my mole ratio. It's always where you're going to over where you're coming from. So I'm going to take the mole ratio, then I'm going to multiply it by that 0.1506. Okay? Now, I'll do the same with my manganese. I'm going to go 2, which is 2 moles, over from, which is 16 moles, times the shift. The shift is defined by the limiting reactant. So do you see, each time I'm multiplying it by the shift of the limiting reactant. Now this time it's 5. It's always the coefficient of where you're going to over where you're coming from, and then I'm going to multiply it by my limiting shift. Because these relate not on a one-to-one basis, but based on their mole roads. This is going to be the same. I've already seen this one. But this time it's a loss, not a gain. We lose reactant and we gain product as the reaction proceeds to completion. And completion is defined as when the limiting runs out. Okay, so now to get to the stop, your stop is equal to your start plus your shift. So let me erase this here. If you get a negative number at this point, you know you picked the wrong limiting, and you'll have to go back and start fresh, which is a hassle, but it's not, irretrievable. You can do that. Okay? So now, if I take my start plus my shift equals my stop. So here I get 0.153 moles, and here I get 0.0188 moles, 0.0188, and I'm not worried about sig figs until I report an answer, so I'll carry a few things along. Now, let's look at what it asked. It asked us how many liters. Okay, so let's address that. How many liters of Cl2 were collected? And it gives me a pressure and a temperature. Well, if I have a gas and I have moles, a pressure, and a temperature, hopefully you realize that would be PV-nert. So that step here, that how many liters of Cl2, now becomes a pretty straightforward PV-nert problem. So I have 99.93 kilopascals times my volume. I get my moles. I already have that. Converting from moles, you should be pretty familiar with all the ways we can convert to and from moles. You have to memorize that R is 8.314 for kilopascals. Remember, you have to have Kelvin for your temperature. So I went ahead and converted this to Kelvin. And if I do my volume, and since I started with HCl with 2 sig figs back here, I'm going to report my volume as 1.1 liters. So that's one of my answers. Now the question asks us, how many moles of the limiting reactant remain? Well, that's right in my chart. 0 moles. It says how many moles of excess are remaining? Well, I've already done that calculation. It's 0.153 moles. If the question had asked me for mass, moles to mass, use molar mass. So there's a lot of ways that we can get from moles to the desired unit. But the advantage of this chart is everything falls into place logically. Whereas in pre-AP, you might have had to memorize the steps, especially, I'll tell you right now, the trickiest part of these is getting the excess remaining. And that falls into place beautifully. You don't have to memorize steps of do a stoichiometry from here to here and subtract this from that. Bam, we've done it. It all falls into place. And not only that, I hope it's very logical. So you'll have some of these to do on WebAssign. So until then, this is signing off.